Welcome to the Stratasys press event at SolidWorks World 2017 from Los Angeles. It is a real pleasure to see so many here with us today, so many familiar faces and many new faces. And to all those on our live stream, welcome also. We have a very exciting event here planned today. My name is Tim Bowling. I'm the Chief Marketing Officer at Stratasys, and I'm going to be joined today by Rich Garrity, the President of the Americas, as well as Jesse Hahn, one of our key customers who has experienced what it is we're going to announce today to the world. We shape what's next is the theme here, and it's all about innovation. One of the key themes for the SolidWorks World Conference, as you all know, in today's world of innovation, collaboration and design and coming together, that's really what we're also going to be sharing, is how we within Stratasys are announcing innovation that matters. Innovation that matters to our customers, innovation that matters to our industry, innovation that matters to the world as we advance the use of 3D printing, additive manufacturing in very specific use cases. 3 months ago, our CEO, Ilan Levin, shared with many of you our point of view of the industry in motion. We believe this industry is evolving to a very specific use case orientation, value add, outcomes. It's not the one size fits all generic printer of the days of the past. Today we're entering an era within the industry where we're unlocking specific outcomes, specific use cases by knowing deeply how our customers use our technology to improve the outcomes that they are looking to realize. The era of specialization, whether it's in the aerospace industry or the consumer goods or automotive or healthcare or education, we are going deep from a specialization perspective with our customers, designers, engineers, really looking to understand how they are using our technology to the betterment of the outcomes that they deliver. And today, the innovation that we are announcing, we believe, is a game changer for our industry as we move forward here. So again, we're delighted you are with us. For those that were with us at IMTS in Chicago 6 months or so back, you saw our point of view, our innovation relative to 3D demonstrators within the manufacturing space, as we are very purposefully moving into the manufacturing space with our Infinite Build 3D demonstrator, our robotic composite 3D demonstrator. Those were examples where we're leading, we're shaping what's next from a manufacturing perspective. Today, the focus of today's announcement is in continuing to lead in the high-end rapid prototyping space. Continuing to lead in the high-end rapid prototyping space. Again, based on understanding our customers' workflow, understanding the requirements from a solution standpoint. You'll hear today what we refer to as a solution, which is much more than a printer. Hardware, software, services, really pulling together those key components to help raise the game, and we believe extend the usage of 3D printing and additive manufacturing. A little over a year ago, we conducted a survey of over 700 engineers, designers, and C-suite executives that are focused on the usage of 3D printing. What that survey concluded was 23% of upwards of a $15 billion marketplace is today addressed by 3D printing and additive manufacturing. What we're announcing today, we believe, expands the market segment for 3D printing and additive manufacturing specifically in the rapid prototyping space, but certainly is applicable to those other areas I shared earlier as well, tooling, manufacturing. But again, the focus of this discussion, the focus of the innovation that matters that we're announcing today is from a prototyping standpoint. Prototyping may have been the first port of call in 3D printing. It still has tremendous potential, So what will it take to make 3D printing a viable solution for widespread adoption? What we're announcing today can be referred to as a smarter prototyping solution. And it's purposeful that we say solution. It includes hardware. It includes advancements from a software perspective as we really pull together those key requirements to help drive improved outcomes for our customers. And that's really what we're focused on, understanding the customer's use case, putting a solution in place to help address that need, to help unlock future benefit for our customers. So with that as framing the announcement today, framing the launch, if you will, what I'd like to do now is introduce Rich Garrity to go a bit more specific and unveil what we're announcing today. Rich?
All right. Thank you, Tim, and good afternoon, everyone. My name is Rich Garrity, and I lead our Stratasys business in the Americas. On behalf of all of our Stratasys employees in the Americas and around the world, we're very excited to be with you here today to share our latest innovation, which we believe is a real game changer for the rapid prototyping space. As Tim noted, we believe that rapid prototyping still represents a growth opportunity for Stratasys and for the industry. We believe that there's significant untapped opportunities within rapid prototyping, and we believe that the solution that we're going to unveil this afternoon will go a long way towards addressing the challenges preventing the further tapping of that growth in prototyping. Speaking of use cases with regards to rapid prototyping, as we've worked with our customers over the years and over the decades in prototyping, we've come to understand three main types of use cases within rapid prototyping. The first one has to do with concept verification. This is giving designers, engineers, students the ability to fail fast. They want solutions that are easy to use, that are accessible, and that are reliable and consistent. The second category has to do with design validation. Here we see designers, in many cases, still using handmade methods to validate their design, whether they're making that out of foam or cardboard or wood or outsourcing to a local shop to have their design sent back out of something machined out of plastic. We know these designers are extremely busy people, are multitaskers in dealing with lots of different complexities in their day-to-day work. They want solutions in 3D printing that are extremely intuitive, don't take a long learning curve to get up to speed on, and also are extremely reliable and give them the ability to create their designs, validate their designs in various sizes, and also with the freedom of design that additive brings and being able to create designs with a lot of complexity. The third category has to do with functional performance. Here we see demand around prototyping real materials for real-world applications, whether to check the fit, the form, the function. For this group of users, the breadth of material offering is very important. The performance of the system, very important. The software, the workflow is very important. And the total cost of ownership, of course, very important. Across all three sets of use cases, we see some commonality in the requirements of these users. Whether it's a work group, a design team, a group of students working together in an education setting, ease of use, accessibility, accuracy, repeatability, versatility, office-friendly nature. These are all characteristics that we see the market looking for out of the ideal rapid prototyping solution. And as we've surveyed and studied the market over the years and working together with our customers, we found that our customers are demanding a better one-stop shop solution for all of their rapid prototyping use case needs. And so at Stratasys, we set out to develop and deliver an end-to-end solution for concept verification, design validation, and functional performance. As we did this, we thought much more than just the printer. As we studied together with customers and observing them in their environments, really understanding what the pain points were with the workflow of how you go from concept all the way through to functional prototypes. And so we set out to develop a solution that truly meets the needs of our customers, integrates into their end-to-end workflow, and is something that's more than just the next new printer from Stratasys. We're building on decades of experience and expertise in FDM technology. We're pleased to be joined here this afternoon by our founder and inventor of FDM technology, Scott Crump. Scott was and is one of the pioneers of the 3D printing industry, inventing fused deposition modeling technology in the late 80s in his garage with his wife, Lisa, as they sought out to create a toy froggy for their 2-year-old daughter at the time. The company was founded and continued to build and lead on new innovations in the marketplace. Years later, 2002, came a real breakthrough where we introduced the first industrial-grade, office-friendly, rapid prototyping system that we called Dimension. This was a breakthrough at the time, getting underneath the $30,000 price threshold. And at that time, competitive systems were selling for hundreds of thousands of dollars. The Dimension line created thousands of new users around the world and exposed a whole new group to 3D printing for rapid prototyping. We've continued to push the boundaries of FDM further down the development cycle, pushing it now into manufacturing tooling and early stage production parts as well. We launched the Fortis line in 2009. We launched Ultim 9085 material, which carries an FST or flame, smoke, and toxicity rating, which allows commercial airline manufacturers such as Airbus or defense companies such as ULA to be able to use the FDM technology combined with Ultim 9085 material to actually put this in real flight, whether it's on commercial planes or in rockets that are launching. And of course, last fall in Chicago, we were pleased to introduce FDM in a whole new way with our Infinite Build 3D demonstrator and a robotic composite 3D demonstrator. We're very excited to be with you today to change the game again with regards to FDM and rapid prototyping. So today we're pleased to announce the new Stratasys F123 series, designed for the way our customers work. We've designed this series from the ground up based on observations, discussions, interactions with customers and their understanding of how they use tools for prototyping over the years. And we've developed an end-to-end solution for prototyping, combining the best of engineering-grade FDM technology with easy-to-use, intuitive software from GrabCAD. Let's now take a look inside the new F123 series. Bit of a video. Okay. We'll take a look later inside the new F123 series. So we've got a 90-second video that will be available to you in press kits and also on our website following this press conference. What you'll see in that video, and what you'll also see for those that are here in visiting our booth and actually seeing the new system, is that this is the most reliable, economical, and intelligent 3D printing solution for the entire office. We worked hard on the economic piece and the total cost of ownership. The system itself prints 25% faster than today's Dimension or U-print printers that are on the market. We have a fast draft mode that allows you to double the speed from there. 4 materials are available for the system, including ABS, PCABS, ASA, and also PLA. This is the first time that PLA as a material is available on Stratasys 3D printers, and we've added that at the request of customers, particularly customers that are looking for a material on the concept verification side that want to do the fail fast mentality and have a even more economical material. PLA is now available as well. The material changeover options on this printer are incredible. You can flip materials from one to another, and you can see this on the show floor, in under 1 minute. The software itself to run the printer is extremely intuitive. We're using our GrabCAD print software, which even the most novice designer to 3D printing will find very useful to be able to get up and running in printing parts. The system itself comes loaded with a user-friendly interface as well, very interactive. And it's great for work groups who can start jobs, monitor jobs, all remotely or around the office, being able to have it networked and then also available for remote status on any mobile device as well. Furthermore, we're pleased to announce today, particularly here at SolidWorks World, that we have a new add-on in our GrabCAD print software, which now allows SolidWorks users to be able to work directly from their native SolidWorks package and drag and drop files into GrabCAD and be able to print immediately on the new F123 series and more. We think this will open up a whole new realm of 3D printing possibilities for SolidWorks customers, and particularly the workflow here is extremely seamless to go from SolidWorks through to final part. Speaking of reliability, this is a company, Stratasys, that's been at this for nearly 3 decades. We have a lot of experience and expertise in FDM, particularly for prototyping, and we're pleased to showcase new innovations with regards to what we've done here. We have 15 new patents pending just for this system alone. Has to do with the extrusion head, toolpath algorithms, how we're handling the support generation, and so forth. We're also leveraging 43 existing patents that we have from the Fortis line, Dimension line, U-print lines as well. And this is a system that's built to be the most reliable rapid prototyping system in the market. When you get inside and take a look at the system itself, all of the componentry is high performance, very durable. The toolpath controls, very extensive, and very much leveraging Stratasys' proprietary expertise of the secret sauce, if you will, of how to make the system work consistently and reliably. The system is built to be used by work groups in office settings and in education settings, so very rugged frame and enclosures and so forth. And the system itself has been through over 90,000 hours of testing. We've had 10 beta customers around the world using the system around the clock. since September. And we're pleased to have one of them with us who will share the story of what he's seen so far in just a couple of minutes. We have 3 different printers in the F123 lineup. We start with the Stratasys F170, which is a 10 by 10 by 10 build chamber. Features ABS, PLA, and ASA for materials, and also comes with GrabCAD print. We then move to the F270, where we go larger, so 44% larger than the F170 in terms of the build chamber. And then to the F370, which is nearly double the size of the F170, 36% larger than the F270. And here we add PCABS as a material option for those functional prototypes, fit, form, function. Additionally, for FDM users over the years who've grown to know and enjoy the advanced capabilities of Insight, Insight is also available on the F370 series. Here's how the new F123 series fits in the FDM portfolio. Okay. This new series is replacing the Dimension and Fortis 250 printers that have been offered today. So while we introduced Dimension to the world as a real game changer, a real breakthrough back in 2002, we believe the F123 series is the next generation for office rapid prototyping and have positioned it such in the portfolio. As we move beyond the F370, we get into our Fortis line 380, 450, 900, where we increase the material options, particularly high-performing materials such as Ultim 9085, as discussed earlier, and we also continue to get larger in the build chamber. So in conclusion, we're very excited to share this news with you today. We believe the Stratasys F123 series is a real game changer for rapid prototyping in the office environment, particularly designed around design teams and work groups to work collaboratively. We think this is a much smarter version of prototyping than what's available today. This is a solution that work groups can use from concept to design validation all the way through to functional prototypes. We believe this is the most reliable, economical, and intelligent solution on the market. And it comes backed by Stratasys, a company that invented FDM technology and has been continuing to push the envelope for nearly 30 years. So with that, I'd like to have you hear from one of those 10 beta customers now. And I'm pleased to introduce Jesse Hahn. Jesse is the president for the Center for Advanced Design, and I'm pleased to have him share his story with you. Jesse?
Thank you. And there we go. Thank you, Rich. As Rich mentioned, my name is Jesse Hahn, and I'm with the Center for Advanced Design. And we were fortunate enough to be selected as one of the beta test companies. And I've been asked to come here today and share my user experience from a user experience perspective. So we are a design firm, and we specialize in complex surface geometry creation for the plastics industry. We are located in Elk River, Minnesota. This is a typical project flow for us, a large-scale project like a vehicle shown here. We handle everything from the front-end industrial design sketch work to creating a 3D model, which of course allows us to 3D print, create the production print packs, and marketing renderings like you see there on the right. On the bottom are the key pieces of software and hardware that truly are the foundation of our company. I'd like to share a couple of use cases with you just to give you some background on how we use the FDM technology on a daily basis in our company before I jump into a little more details about our beta story. So this is a snowmobile build that we did, a ground up. It was actually launched at SOLIDWORKS World 2014. And what we're showing here is a quarter scale model that was concept verification. And this is a combination of FDM technology and PolyJet. And I should mention at this point that 90% of the use cases I'm going to share today are or were printed on our F370. So the next one I'd like to share with you is a kit that's sold by Polaris. So I know I said Polaris, and this is a Kawasaki picture here, but the kit is a division of Polaris called Timber Sled, and they make kits to convert your dirt bike to a snowmobile. And we worked on this kit. We used FDM technology to develop the entire kit throughout, but I had one part here I wanted to point out. This is a bearing carrier. To get the output shaft of the motor out and around the track, we had to extend it by about 2 inches, and this is meant to support that output shaft. And we actually tested the 3D printed product. Here's some shots of it in action. So here's another use case I'd like to share. This is a product called Skyride, and this is a project we did for Carnival Cruise Lines, and their new Carnival Vista has a monorail on the upper deck that runs the perimeter of the ship. In a couple of spots, it actually juts out and over the ocean. You're about 300 feet down to the ocean. We developed the cars that go on this monorail system, and we used FDM to help with the assembly fixture. So this product comes down the line. 2 shell halves come together, but there's a bunch of internal components that need to be assembled. So those get inserted, and then the 2 halves come together, and we put these caps on with pins, and then that facilitates the rest of the assembly. They're actually the last part that comes off on the assembly line. We do a lot of cab systems for utility vehicles at CAD, and we use the FDM technology throughout the entire design process. So on the upper right there is a really important piece. This is a clamp, over-center clamp that holds body panels on the vehicle. And it's not uncommon for us to print over 100 of these clamps. They actually help facilitate the design and development of the remaining components of the cab system. In the middle, there's a design verification piece that is a part that we printed and actually bolted to a vac form tool to prove out a costly change that was going to have to be made. We had already aluminum tooled the product, and we were able to bolt this printed part on top of there, draw plastic down, prove out the change, and get the go to make the expensive tool mod. The bottom right is another piece that's used on the assembly line. This is for a rotomolded component. The part would go in there, the 2 halves slide together, and then that FDM piece you see there on the top drops in and locates a couple of mounting bosses, and then we pump air into the part to cool the part right on the production line. This is a really cool company. I actually brought the part with me. I wanted to share this story here. So this is Mike Schultz. He's a snowcross racer and a motocross racer, X Games, and he lost his leg in a snowmobile accident. And he came to us. He had a functioning prototype of what he needed to get back on the bike and back on the snowmobile to work, and we helped him make that part manufacturable. And this is a picture of the design verification piece. This is the FDM, again, combined with a few polyjet pieces, but the component uses 2 air mountain bike shocks, 1 in the knee, 1 in the foot. And I've got some footage of this actually working. So Mike actually has 3 products in his offering. He has, to date, outfitted over 700 action sports athletes with this prosthetic. The VersaFoot and the Moto Knee are what was shown in the video. And behind there is a product called the Alpine Foot that we designed for him. This is another great case study for the FDM technology. We actually printed the original foot. This is a picture we found of the very first day we tested. We put this together. We called Mike and had him meet us at the ski hill. He actually skied for about 4 hours that day on that, running some gates at the end of the night with absolutely no issues. And the product he sells today does not look far off from what we actually tested that very first day. So with that, I'd like to switch gears and focus on our beta story. This is one of my favorite slides of the whole presentation. This was kind of one of those wow moments for us with the product. From the minute that the shipping crate, we were selected for the beta program, from the minute the shipping crate hit our dock, we uncrated it. It's got a great ramp piece that comes down, and you actually wheel it into the office. You plug it into standard power. We didn't have to have an electrician on staff. We were able to just power this up ourselves. And you have 3 options for getting your files to the machine. You can use Ethernet, you can use Wi-Fi, and you can use a thumb drive. So we plugged the machine in, installed the software, and printed our first part, all within 30 minutes of that crate hitting our dock. Here's some pictures of the machine rolling into our office here. And just wheel it right into location. We also tested the 3600 washout tank. I'll get a little more into that later in the presentation. This is a video I wanted to share. This is our very first part coming out of the machine. You'll see there's a new eject system for the tray. The tray pops right out. One of the first things we noticed is how flexible these trays are. Makes it absolutely easy to get these parts off of the tray. Very clean. And then the washout tank has a double door system. It helps keep that machine looking clean. It sits right in our design firm, so we need it to be looking good. You saw me lift the basket up, and it sits on a little kickstand. You drop your parts in, lower the basket down, and close the doors. Here you'll get a great shot of the interface, very user-friendly. This was another one of those wow moments for us. We went to change out material. You can see I grabbed the roll here. The material starts threading out of the machine. I'll drop the new roll in, and the chip's there on the side. It automatically recognizes the material, recognizes the color. I feed it in about 4 inches, and I hit load on the machine, and it takes care of the rest for you. So what you saw me do is literally unload and load material in under a minute there. This is another one of the wow moments for us as well, changing out the head. So I just take the filament line out, disconnect the electrical, and I'm going to turn a cam here, and that head pops right out. So the cool thing about that cam is that cam stays in the open position until you drop the next head in, and then when you push down, it'll automatically release. Plug the electrical in, hook up your filament line, and I just changed the head in under a minute. The machine takes care of the rest. It'll automatically recognize the new head. GrabCAD was new to us as well, so I just wanted to share our experience with that. This is that same part in SolidWorks. It's a cell phone case. So I'm going to go ahead and drag and drop that right into GrabCAD. And a very cool interface, very intuitive. I'm going to grab the positioning controls here, and I'm going to lay my part down. And you'll see me select the material here. I'm going to choose ASA, and then I'm going to hit print. And across the top, you'll see the processing bar, and this is real time. This is just how fast this part processes. So once your part's processed, it builds a graphic interface for you to work with. And you can see I can zoom in, and I can see exactly how my part's going to print, down to the finest detail. There's a slider bar on the left, and that'll let me drag and I can toggle through every single layer, which is really important. So if I've got a 40 or a 50-hour build that I'm running, I'm going to find out exactly how that's going to print before I spend the money on the material and the time in our machine. So with the GrabCAD software, we also ran the GrabCAD server app for your mobile device. So I can log in from anywhere, and I can check the status on a part. I literally just checked it about 45 minutes ago before the presentation here. I'm able to toggle over, and I can check my material base, see what's loaded, how much is left, and I'm also able to adjust the queue. This is the part I wanted to highlight at this point because we had used some other printers in the past that printed PLA, and we had somewhat of a bad experience. The parts weren't perfect, and we had trouble getting the support away from the part. So when we were in the beta program, we were given all the materials to test, and honestly, the PLA was the last one that we tested because of that. And we were really kicking ourselves that we waited so long to try this. We were absolutely blown away by how well the support breaks away from the part and how clean and how functional these parts really truly are. Not even to mention the speed, which I'm going to get into later here. This is another project that I wanted to highlight. I've actually brought some parts with us here today. So the customer had some feedback. They had some ventilation issues on a project we did about 2 years ago for them. And then they wanted some accessory mounts for some of the new cameras that people are using on the helmets. So we split up the task. We were on a very tight timeline. We split up the task between all the designers in the firm. And they're all connected. They were all connected to the F370. So as they finished their product, they would upload it. I could go into the queue and organize by priority. And we started printing. So here's a shot of the visor being printed in our F370. And I also have video of the shell itself. This is another one of my favorite slides of the presentation. So when we did this project 2 years ago, we were operating off of a U-print, and we had to section and dovetail this into 6 pieces and glue it together for the customer. So being able to walk into that design review meeting and have a one-piece unit all printed in one build chamber was absolutely amazing. It was kind of a game changer for us at that point. I wanted to share some of the stats from that build with you. So the final product that we printed, that we presented to the customer, was ASA. We printed 10 slice, so 10 thousandths layer. And you can see the model and support about 80 cubic inches. It took 55 hours to print, and it's a great looking model. We had some features that were going to snap together on this helmet, and we knew we were going to print multiple iterations to get that feel that we wanted, that we knew the customer needed to have. So we decided to run some PLA design verification parts first. And you can see the model material, about 48 cubic inches, so just over half. But here's the big one, the time, 25 hours in fast pass draft mode. So in summary, the things that we noticed that stood out the most to us were obviously the large build chamber. We didn't realize until we had this how often we were finding workarounds for our larger parts and how much time we truly wasted dovetailing and modeling these parts to print and then gluing them back together. The 5 slice or 5 thousandths layer, I have high res written down there because although we were sharing these parts with our customers, we couldn't tell them where they were coming from and we couldn't show them in the machine. But they were looking at the 5,000 slice parts and they started calling them high res and started asking for them by the name high res. Quiet operation. This sits between 2 of our designers in our office and absolutely no issues whatsoever. Print speed. We were coming off of a U-print, and we ran the same model side by side in both machines. And depending on the geometry, we were seeing increases of 20 to 30% in speed. The F370 would finish before the U-print. Easy material changeout. This was a game changer for us. So to this point, we've only offered our customers black ABS. That was all they could get in their prototypes from us. And it was strictly because we couldn't, being a design firm, we charge for our time. And I couldn't have a designer standing in front of the machine waiting for material to change out. Now we're able to change material out in under a minute. That has opened us up to multiple materials offerings for our customers and colors. It's truly made us a stronger design firm because of it. PLA draft mode that I touched on earlier. On certain projects, this has literally changed the way we operate at our company. Being able to fail fast and figure out what's wrong. We're printing early and often to advance these projects faster than we ever have before. The GrabCAD print software is amazing. We use it for 98% of what we print in the F370, and we use Insight for some of the more technical jobs or some of the tooling that we're doing. If we need to fine tune or adjust anything, the options there. Easy installation. Again, in under 30 minutes, you have no special electrical requirements, no electrician needed on staff. You don't need shop air. You just wheel this thing in, plug it in, connect it, and you're printing. And repeatability, this was a huge one for us. So we need to know that when we hit print and we walk away, when we come back the next day or over the weekend, that part's going to be there and it's going to be done right because we commit to our customers when it's going to be done. And this machine gave us the same confidence that we were used to from all the Stratasys products and the U-print that we've been using for so many years. So I just want to thank you very much.
Thank you, Jesse. Really appreciate you sharing your story with everyone here today. What I'd like to do now is pivot to the question and answer session, and to help drive that, I'd like to invite Scott Crump up to the front of the room, please. Scott, Pat Carey. So Scott is our founder, as we mentioned earlier. Pat is our Senior Vice President of Sales for the Americas. Kathy Hansen. Is Kathy in the room here? If Kathy can join us here, that would be great. Kathy is the product manager for the Stratasys F123. And Roger, if you could join us as well. So we've got the full team here. Roger leads our sales enablement efforts here from a global perspective as well. So what we'd like to do now is, again, open this up to question and answers. I hope we have a couple of mics here that we can share. So let's do the video.
After the Q&A.
So let's start with the Q&A here, if you would please, right here at the front. And team, we've got a mic here as well, so please.
Let's start with the really easy question: pricing and availability. When are these available, and how do they? What's the cost differential between the new machines and the machines they were replacing? And then I have a follow-up.
Sure. Rich, you want to?
Yeah, so good questions. So I think the important thing to keep in mind here is that we're taking a lot of the functionality that you've seen over the years in some of the higher end systems and bringing it into this F123 series. And so we think as part of that, we're changing the game on total cost of ownership and so forth. The series itself starts at sub 20,000, the F170 series, and goes from there. Specific commercial pricing details on all the models, all the accessories and so forth are available through our commercial partners. We are taking orders this week now for the system here in the United States, and we're beginning to ship the product in March.
Excellent. Now, at the very beginning of the presentation, you had a slide. There were three things, and all the way on the right was this move to the manufacturing side. And this announcement today doesn't address the let's say manufacturing at scale side of the equation. I'm wondering if you could just say a few words about what Stratasys is doing on that aspect of the operation.
Yeah, so we're doing quite a bit on the manufacturing side. As we shared at IMTS in Chicago, we really believe that the next major wave of growth for the industry is going to come from additive manufacturing use cases. We think a lot of those use cases will be very specialized in key markets such as aerospace, automotive, healthcare, and so forth. What we brought to IMTS was a demonstration of our commitment to manufacturing. So we showcased 2 new systems at IMTS, including our Infinite Build 3D demonstrator and our robotic composite 3D demonstrator. We did that together with partners, so industry leaders in manufacturing. On the Infinite Build system, we've been partnering with Boeing for a number of years in the development of that system, and we announced that at IMTS. And on the robotic composite demonstrator, we have a partnership ongoing with Siemens, where we're working on bringing that solution to market in the coming years.
Okay. Thank you. That was exactly what I wanted to hear.
Other questions? Yeah, good question here.
Hi, hello, Joe. For Mr. Bowling, I think that you can answer me. When you talk about penetrate in manufacturing, which sectors are your goal or the main goal?
Yeah, so from a company perspective in the manufacturing space, we've been very focused in select areas. Aerospace, automotive, certainly very, very important. The healthcare space is another area. To name a few of the applications that Rich had shared earlier with respect to the Infinite Build 3D demonstrator and the robotic composite. Those are a couple of areas that we certainly have deep experience, strategic partners, and great customers that we plan to continue to focus on. Any other questions here at this point? Yes, please.
You said that orders from US customers, or they can place their order this week, and you start the shipping in March. But what for Europe and the rest of the world?
So also shipping in March. Details on specific ordering windows and so forth are available from our partners in each of those regions.
All right, perhaps we have time for one more question over here. And then there's an opportunity for one-on-one discussions with our leadership team as well following this press conference. But let's have one more question.
It's a question for Jesse. When you build prototypes for your customers, obviously you build that into their costs. So if you get the parts quicker, does that mean you provide them cheaper, or do you make more margin on what you provide to your customers?
That's a great question, and the answer is more margin. So it's a win-win for us. We charge by the cubic inch, so that's how it works out for us.
Okay, with that, again, I'd like to thank you all for joining, those on live stream, those here in the room. It's a pleasure to see so many of you here with us. I hope you share our excitement for what we have announced today. We do believe it's a game changer. And in closing, we do have media kits available. And for those on our PR team, if you could please raise your hand. If you want to have one-on-one discussions, please feel free to reach out to anyone here on the PR team, and we'd be happy to have discussions with you following this event. So with that, thank you. Have a great day. Come on in.